This is Geometry, Unit 5, Day 3. We're talking about the properties of a rhombus, a rectangle, and a square. A rhombus has four congruent sides. A rhombus is a type of parallelogram. So is a rectangle and a square. So it's going to have all the same properties that every parallelogram has. Opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals that bisect each other. It has all those properties plus a few extra. A rectangle is a special parallelogram, so it has all the properties of a parallelogram, but it also has four right angles. The IFF, that stands for if and only if. We'll have a rectangle if and only if we have four right angles. The if and only if means that you can read it the other direction also. If you have four right angles, then you have a rectangle. A square has to have four right angles and four congruent sides. So a square is always a rhombus because it always has four congruent sides. But a rhombus is not always a square because a rhombus does not always have the right angles. So a square is a rhombus and a rectangle put together. So for our first example, we're going to sketch out a rhombus. So R, S, T, V. Remember, the R can go in any corner, but when you label them, they have to be consecutive. So the R and the T have to be across from each other. The V and the S have to be across from each other. You can't say R, S, T, and V. You've got to go in consecutive order. Now the question is, will S and V always be congruent? Sometimes be congruent. In this case, because a rhombus is a type of parallelogram, we know that opposite angles are always congruent. So if you have a parallelogram, which a rhombus is a type of parallelogram, then opposite angles are congruent. That's always going to be true. Will T and V be congruent? T and V are considered consecutive angles. We know that the consecutive angles of any parallelogram have to be supplementary. Supplementary does not have to be congruent. That just means it has to add up to 180. Could it be congruent? So, are there any two angles being exactly the same that would add up to 180? So, of course, sometimes. Only when angle T and angle V are right angles. Because 90 and 90 would make 180. They could be supplementary. Now, you might be thinking, well, that makes a square. Well, a square is a type of rhombus. A square has four equal sides. So the only time that consecutive angles would be congruent is when you actually have a rectangle, which is a square if all four sides are the same. Next, we're looking at this shape. We're going to classify it. What shape would this be? More importantly, why? We know that it has four congruent sides, so it falls underneath a rhombus. It's a type of parallelogram, but it's more specifically a rhombus. Notice that we have 127 degrees. That means it's not 90. That means it's not a square also. It's just a rhombus. If a quadrilateral has 4 congruent sides, then it is a rhombus. So we know for sure that this is a rhombus, and it can't be anything more specific than that. For any square, so I'll draw a possible square that has 4 right angles, 4 congruent sides, and is named CDEF. You can put the C on any corner you want. The D has to be in consecutive order, so you can't put the D across from it. Now the question is CD, which has 1 tick mark, congruent to DE, which has 1 tick mark? And of course, it's always going to be congruent. A square has 4 congruent sides and, very importantly, 4 right angles. The question is, are the consecutive sides congruent? And the answer is yes, they're always congruent because all 4 sides are the same. On this next side, we're looking at a parallelogram, and a parallelogram is a rhombus if and only if, that's that IFF, if and only if the diagonals are what? What's happening with the diagonals? If you look at the picture, you'll recognize that they show the box in the corner. So that means they're forming a right angle. So we call that, the diagonals would need to be perpendicular. And the symbol we use for that is that upside down T. So AC is perpendicular to DB. The parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Each diagonal, notice that this diagonal comes through here, it's cutting this big angle into 2 parts that they both have 2 tick marks. They're both sides are congruent to each other. This diagonal is coming through and bisecting this big angle into 2 congruent parts. That is true about any rhombus. So anything with 4 congruent sides is going to bisect those angles. So ADC, let's see, segment AC, that's this one, is bisecting DAB. And it's also dissecting BCD. BD bisects ADC and also bisects angle ABC. So a property that is true about a rectangle, a parallelogram is a rectangle if and only if its diagonals, now let's look at the picture, what's happening with these diagonals? They don't seem to have right angles. That doesn't look to be very much like perfectly a square. I see that the tick marks are on the diagonals, and that's showing that they're both the same on either side, so they're bisecting each other, but they're bisecting each other on all parallelograms. So it's more than just bisecting each other, they're all the same length. So the diagonals are congruent. So AC is going to be congruent to DB. And that's true for any rectangle. A square is a type of rectangle, so a square is going to have congruent diagonals. Let's make ourselves a rectangle. So we have a four-sided shape with its four right angles. We'll name it F, G, H, J. And we're going to list everything we know about it. So, different things that we know about a rectangle, it might help you for a chance to list them all, is to start not very specific and then work your way to being very specific. So it's definitely a polygon. It's made up of segments. It has four sides. So we know it's a quadrilateral. It's a special type of quadrilateral called a parallelogram. So it's going to have all the properties that a parallelogram does. It's going to have opposite sides congruent. Going to have opposite angles congruent. Consecutive angles are going to be supplementary. So, do you know what each one of these mean? Do you know what opposite sides are referring to, or opposite angles? Do you know what consecutive angles are supplementary? What does that mean? That means one after another have to add up to 180. So 90 and 90 adds up to 180, or 90 and 90 adds up to 180. That's true. That's always true about a rectangle. Diagonals bisect each other. That's true about every parallelogram. So that's going to be true about a rectangle. We also know that this has four right angles. That's pretty specific. That's only true about a rectangle. What else do we know about a rectangle? Diagonals are the same length, so they are congruent. We also know that the sum of interior angles equals 360. That would be true about all the angles of any quadrilateral. The interior angles, the four interior angles, will add up to 360. So that would be true about a rectangle also. So here's how it can be used in the real world. If we're making a rectangle, if you're making cabinetry, or in this case a frame, the frame must be a rectangle. Given the measurements in the diagram, can you assume that it is a rectangle? So we look at this shape and we notice that the opposite sides are both 20, opposite sides are both 16. So does that mean that if those were the measurements of the pieces of wood that you received, would it guarantee make a rectangle? Well, it can't make a rhombus because they would all have to be the same. If I have this example that I have two sides the same, they're like both 20, and two other sides both the same, say 16, I can move around depending on how the 16s are slanted. So only if they were exactly right angles. But in reality, when you're putting big cabinetry or frames together, there's a chance that it would be a little bit off. So it wouldn't be square. We call it square when a corner is 90 degrees. But it wouldn't be a rectangle. So can you assume that it's a rectangle just because opposite sides are congruent? would say no. It might not have right angles. Now, if you're looking at a possible rectangle, and if we measure the diagonals are about 25.6. If the diagonals are both the exact same, can we call it a rectangle? As long as the diagonals are both the same length, then it will be a rectangle. So what can we conclude? If the diagonals are the same length, then we know for sure that it's a rectangle. Up here the property said a parallelogram is a rectangle if and only if the diagonals are congruent. So if diagonals are congruent, then the quadrilateral is a rectangle. Suppose the diagonals of a frame, and this should actually be example 5, are not congruent. Could the frame be a rectangle? And again, no. Diagonals of a rectangle must be congruent. Otherwise, it won't make a rectangle. It won't have right angles if the diagonals are not the same length. If one is shorter than another, then to make it shorter, you've got to bring those closer together, which is taking it away from right angles. For them both to be the same, you've got to keep separating so they can become the same. And there's only one magical spot that they're as far apart as you both can get, and that would be to have right angles. For the last example, we're looking at example number 6. We're given some information about our rhombus, and we're supposed to identify what is the measure of WZV. So what is this measurement? Well, I say we have a diagonal, and I know from a property that the diagonals of a rhombus will bisect the opposite angles. If we have a rhombus, then diagonals bisect opposite angles. So if this is 34, that makes this side have to be 34. Now it asks us for the measurement of XYZ. XYZ. That's this big angle. There's a couple different ways we can look at this. This big angle is next to or consecutive with this big angle. If we have a parallelogram, then consecutive, let's just say consecutive angles are supplementary. What that tells us is if this is 68, then this has to be 112. 180 minus 68 so that has to be 112. WY, what's the length of WY? Well, if WV is 7, I know that the diagonals bisect each other with a parallelogram. If we have a parallelogram, then diagonals bisect each other. So that makes 7 here and 7 there. So YW has to be 7 and 7, which is 14. And then finally, what is the length of XY? Well, if we know that WX is 10, so if we have a rhombus, then we have 4 congruent sides. So that makes this 10 also.